Okay, peeps. One of the things that you're going to have to be able to do if you're doing the higher paper within the quantitative chemistry section is be able to do calculations from equations. Now, this bit down here at the bottom, the masses of reactants and products can be calculated from balanced symbol equations. That's quite an important thing that you've got to be able to do. It's usually worth a reasonable number of marks. Now, it's about making sense of balanced equations. So let's take a look at an example here so you can try and get your head around about what you'd be expected to do. So here's a question. What mass of calcium oxide, so this is calcium oxide, could be obtained by heating 25 grams of limestone? That's the limestone. So we're going to heat 25 grams of limestone, and we want to know how much calcium oxide we're going to get from heating 25 grams. First thing to notice when you see a balanced equation like this is that you've got to look at how many moles of calcium carbonate, or the limestone, makes how many moles of the calcium oxide. So we have 1 mole of calcium carbonate or limestone making 1 mole of calcium oxide. Now it's important that you understand what the relative molecular mass of both of these substances are. So the relative molecular mass of the calcium carbonate is 100. What that means is 1 mole of calcium carbonate will be equal to 100 grams. We also have calcium oxide here, and 1 mole of calcium oxide will be the equivalent of 56 grams. Okay, so 1 mole makes 1 mole. So if we had 100 grams of the limestone, the calcium carbonate, that would mean that it would make for us 56 grams of calcium oxide. Now, our question is asking us how much will 25 grams of the limestone make for us. So to answer that, what we need to do is work out how many grams of calcium oxide will we get if we had 1 gram of calcium carbonate. So 1 gram is the same as 56 over 100, which is going to be 0.56. Therefore, 25 grams of calcium carbonate, the limestone, will be the same as 25 times 0.56, which, if you plug those numbers into your calculator, you will find is 14 grams. So there's our answer for this first example. If we have 25 grams of limestone, calcium carbonate, and we heat it to make calcium oxide, we will get 14 grams of calcium oxide. So that's a relatively straightforward one. Now we'll take a look at another example. So in a blast furnace, the compound hematite is converted to iron. So here is our formula, the balanced equation for this. There's the hematite. So 1 mole of hematite, Fe2O3, actually makes 2 moles of iron. So Fe2O3 makes 2 moles of Fe. So we need to understand we've got 1 mole making 2 moles. We've got to look at the relative molecular mass of the iron oxide, or the hematite in this instance. So 160 grams will make 2 moles of iron. Now 1 mole of iron is 56, so that's 56 times 2, and that will work out at 112 grams. So 160 grams will make 112 grams. So we need to know what mass of iron can be obtained from 16 grams of the iron oxide. So first of all, we need to understand how much will we get if we had 1 gram. So that will be 112 over the 160, which will give us 0.7 grams. We have 16 grams of the iron oxide hematite, so 16 grams will be the same as 16 times 0.7. That will give us 11.2 grams of iron. So this question is a little bit more interesting because you're paying attention to 1 mole here making 2 moles here. So bear that in mind whenever you encounter a question that contains more than 1 mole. So let's take a look at another. So this one seems a little bit more complicated, but it's really not. Okay. So what we're being told is that we have 2.67 grams of aluminium chloride. So there's the aluminium chloride. It was dissolved in water and silver nitrate was added to give us a precipitate of silver chloride. Silver chloride. So here's our silver chloride. So what mass of silver chloride will be formed? Now, one of the things I neglected to mention is if essentially we can ignore the silver nitrate and the aluminium nitrate here. We don't need to worry about them, because all we need to worry about is how much aluminium chloride will make how much silver chloride. So what we can see is that 1 mole of the aluminium chloride will make 3 moles of the silver chloride. So 1 mole of the aluminium chloride, as we can see here, will be the equivalent of 133 grams. Now that's going to make 3 moles of the silver chloride. So that will be 3 times 143, because there's the relative molecular mass of silver chloride. So that will be equal to 429. Okay, so now that we have 1 mole making 3 moles, what we need to be aware of, like the previous examples, how much will 1 gram make? 1 gram will make 429 over 133, which will make us 3.22 grams. So the original question was asking us, we had 2.67 grams of aluminium chloride, so 2.67 will make for us 2.67 times 3.22, which will work out at 8.6 grams. There's our answer. So if you get sort of something that looks like this that's a little bit more wordy, don't panic about it, and look at the information that you're being required to make sense of. So it's the aluminium chloride and the silver chloride. These are the 2 compounds that we're interested in. Don't fret about the silver nitrate or the aluminium nitrate. We're not interested in them. We just want to know how much aluminium chloride will make how much silver chloride, and there you go. You've seen a couple of them being worked at now, and if you want to, what you could do is pause now and see if you can work this one out for yourself and start the video again whenever you want to see what the solution is. So for this one, sodium azide, NaN3, decomposes on heating to form sodium and nitrogen. This stuff is what they put into airbags because it makes a lot of gas very quickly. We get from 2 moles of sodium azide, we actually get 3 moles of nitrogen, so it's a lot of gas, and that helps to expand the airbag. Anyway, calculate the mass of nitrogen that would be produced when 130 grams of sodium azide decomposes. So what we have is 2 moles of sodium azide and 3 moles of nitrogen. So 2 moles makes 3 moles. So the sodium azide, we can see will have one mole will be 65 grams. But we need to understand how much 2 is. So it'll be 65 times 2. It should be 130 grams. Is going to make 3 moles of nitrogen. So the relative molecular mass of N2 is 28, so that will be 28 times 3, which will be equal to 84 grams. So we have 130 grams making 84 grams. So, usual method, how much will we get if we have 1 gram? So that will be 84 over 130, which is going to give us 0.646 grams. And the question is asking us, we've got 130, so obviously 130 is going to make for us 84 grams. So this is from an or a past GCSE paper, so you can see it was relatively straightforward. We almost had the answer whenever we did the first part of the question. 84 grams might not seem like a huge amount, but in terms of the volume of nitrogen that's quite a large volume, which is one of the reasons why this is quite a useful reaction for helping to fill an airbag if a car accident happens. Okay, so let's move on to another one. Again, if the video and then check your answers after you've done it for yourself, please feel free to stop. This time we need to calculate the mass of ammonia that could be made from 1,000 grams of nitrogen. So 1 mole of nitrogen makes 2 moles of ammonia. So 1 mole makes 2 moles. 1 mole of nitrogen is 28 grams, and that is going to make 17 times 2 moles of ammonia, which will be 34 grams. So 28 will make 34. So 1 gram will make 34 over 28, which will work out at 1.214 grams. We needed to know how much 1,000 will make, so 1,000 grams will make 1,214 grams of ammonia. relatively straightforward. Again, making sure that you're clocking 1 mole of nitrogen makes 2 moles of ammonia. Take a look at another example, this time again another GCSE past paper question. We need to calculate the maximum mass of aspirin, which is this compound here, that could be made from 2 grams of salicylic acid. That's this compound. So we can ignore these other reactants and products, so don't worry about them. So what we can see is that 1 mole of salicylic acid will make 1 mole of aspirin. So it's 1 mole makes 1 mole. 1 mole of the salicylic acid will be 138 grams. So 138 grams would give us 1 mole of aspirin, which is 180 grams. So usual, now we know how much 1 mole will make, how much will 1 gram make. So 1 gram will make 180 over 138, which will be equal to 1.3 grams. We are being asked how much aspirin will we get from 2 grams of salicylic acid, so 2 grams will make us 1.3 times 2, which is going to be equal to 2.6 grams. So another example of working with equations. You can see it's relatively straightforward and not really something that you should be too worried about. So a couple of examples. Let's take a look at this one. Again, stop the video if you want to do it for yourself and then take a look at the answer. So what mass of sodium chloride will be formed when 4 grams of sodium hydroxide react with excess hydrochloric acid? So what are we interested in? We want to know how much sodium chloride is being produced when we react 4 grams of sodium hydroxide. So you can see that 1 mole makes 1 mole, so it's 1 mole makes 1 mole. 1 mole of sodium hydroxide is 40, so that will be 40 grams. So 40 grams will make 1 mole of sodium chloride, which will be 58 grams. Okay, so 1 mole makes 1 mole. How much will 1 gram make? 1 gram will make 58 divided by 40, which will be 1.45 grams. And we were asked originally how much will 4 grams make. So 4 grams will make 1.45 times 4. That will be the equivalent of 5.8 grams of sodium chloride. Again, another example of working with equations to work out how much product you get from a given amount of reactant. Pretty straightforward. Let's take a look at another. Again, stop the video if you want to take a look at doing it for yourself, and then start it again if you want to see the solution. So this time we have silver chloride being formed when 5.2 grams of barium chloride reacts with silver nitrate, both in solution. Okay, so we want to know how much silver chloride we're going to get, so that's the silver chloride, AgCl, and how much will be formed when we have 5.2 grams of barium chloride. So there's our barium chloride, so we can ignore the silver nitrate and we can ignore the barium nitrate. What you notice is 1 mole of barium chloride makes 2 moles of silver chloride. So that tells us that 1 mole of the barium chloride, 208 grams, will make us 2 moles of the silver chloride. So 2 times 143, that's equal to 286 grams. So you know the score, 1 gram will make 286 over 208, which is the equivalent of 1.375 grams. So initial question was how much silver chloride will we get from 5.2 grams of barium chloride. So 5.2 times 1.375. That tells us that after this reaction's taken place, we will have 7.15 grams of silver chloride. So another one done and dusted. Okay, this one's a little bit more interesting, and this is our last example. So again, stop the video if you want to take a look at doing it for yourself, and click play again when you are ready to see the solution. This time we have ammonia being used to make urea. So ammonia being used to make urea. And a factory produces 6,000 grams of urea each second. So that's a lot of urea. We need to calculate the mass of ammonia needed to make 6,000 grams. So the mass of ammonia needed to make 6,000 grams of urea. This is a little bit different, this one, because we'll see why in a second. So bear in mind, what we see here is that 2 moles of ammonia is making 1 mole of the urea. So 2 moles of ammonia, 2 times 17 is 34 grams, makes 1 mole of urea, which is 60 grams. So 1 gram will make 60 over 34, which is 1.764 grams. Now, this is where it's slightly interesting, because we need to know how much ammonia is needed to make 6,000 grams. So in it, we need to know grams. We need to know this bit here. How much ammonia do we need to be able to make 6,000 grams? So to enable us to do that, we're going to have to divide our 6,000 grams by the amount of ammonia, the amount of urea, sorry, that we would have if we had 1 gram of ammonia. So our 6,000 grams of urea here divided by 1.764, that works out then at how much ammonia will we need. We will need 3400 grams of ammonia to help us to make 6,000 grams of urea. So a little bit backward, that one, but another example of something that you might be required to do, because this is another GCSE past paper question. Anyway, I hope you have found this little tutorial on working with equations useful. Remember that It's working with the masses of reactants and products, and that they can be calculated from balanced symbol equations. So this is something you will need to do if you're doing the higher paper. So I hope this was useful, and check back again and see some more chemistry videos. Thank you very much.